All right, today we are doing section 1.4, day 2 of solving inequalities. Our objective is to solve and write compound inequalities, which is how this will be just a little bit different from yesterday. A compound inequality is a pair of inequalities joined by the word and or by the word or. I know that sounds weird to say out loud. To solve an inequality containing and, find all values of the variable that make both inequalities true at the same time. These solutions can usually be connected into one large inequality, such as 2 is less than x is less than 10. Let's start solving example 1. We need to solve both of these inequalities separately, and then we will graph the solution all together. Okay, so let's focus on the inequality on the left. In order to solve that, I am going to subtract x from both sides. That would leave me with x is greater than 6. So that one was pretty quick to solve. To solve the other inequality, we need to add 7 to both sides. So we end up with x is less than 9. The last part of this problem is then to graph the solution. This is the big important part. So we have a number line. We need to have 0 on it somewhere. I'm going to count by 3s. If you would like to count by some other increment, that's fine, as long as you're counting by the same thing every time you make a dash or a tick mark. When I go to graph these, I have to apply a lot of the same rules that I did yesterday, and sometimes you might want to put a little note above it so that you don't have to go back and erase. So if I were just graphing x is greater than 6, okay, I would put an open point, open circle at 6. Okay, so for my x is greater than 6, I'm going to use this yellowish color. Here's my key off to the side. Open circle, and I'm going to shade it to the right because it is greater than. I'm going to have to go back and take some of that away or erase some of that soon, but for now I'm going to leave it there. Okay, for my other equation, x is less than 9, I'm going to use a bluish color. I want an open circle at 9, and I'm going to shade the opposite direction, because it is less than lower. So now to graph my final answer, the reason why I said I would have to erase some is because for an and inequality, we only want the overlap, or where both of them are true at the same time. The only place it overlaps is in between those 2 points. So now that I see that, I'm going to go back and take away, didn't plan that very well, take away what I drew and only graph the overlap. I'll do it in a different color. So open circles only shaded in between them, which is a very small section of our graph. Again, they're both open because we did not have the equal to bar. We're shaded in between because that's where they overlapped. Yesterday we briefly talked about not doing the whole like open circle and arrow above your graph. This is where that comes in handy. If you do that above your graph, then it's easy to see that they overlap in between. So on these problems, if you do that above your graph just so that you don't have to go back and erase, I'm fine with that. Just make sure you don't leave this as your final answer. Your final answer still needs to be shaded in on the number line. Okay, if we have no more questions about that, we'll go on to example 2. All right, once again, we need to solve each inequality separately, and then we will work on graphing the solution together. It's like 2 problems in 1. To solve my first inequality, I am going to choose to subtract 2x from both sides. If you solved it differently, that's fine. Your answer should come out the same. So we would have -1 is less than or equal to 1x. I prefer for my variable to be on the left, so I am going to rewrite it right now, flipping the whole entire thing over, so that it reads x is greater than or equal to -1. On my other inequality, I have x is greater than 4x minus 9. I'm going to subtract 4x from both sides, which would leave me with a -3x is greater than -9. Next, I have to divide both sides by -3. But what do I have to remember on this next part here? Change the sign in the middle. If we divide both sides of an inequality by a negative, we need to flip the inequality symbol around. Again, -9 divided by -3 ends us with a +3. Doesn't matter that we ended with a positive number. What mattered was that we divided both sides by a negative. Now it comes time to graph. So I have a number line. I am just going to count by ones this time. All right, when I go to graph my first inequality, x is greater than or equal to -1. Do I want an open or closed circle? Closed, very good. Closed at -1. I'm going to do my little notation shorthand above it, so that way I don't have to go back and erase this time. So I know it'll be closed. I jumped ahead. You're going to be shaded to the right because it is greater than. Shaded to the right. And then for my other inequality, x is less than 3. Do I want an open or closed circle? Open. There is no equal to bar, so I leave it open. X is less than 3, lower, left. So I know I'm going this way. But I only want where those graphs will overlap each other. Okay, so I only want this part in between. So I am going to put an open circle or point at 3. I am going to put a closed point or circle at -1. And then I am only going to shade in between them. Looks a little bit different this time. We have it connected instead of separated by the word and. If you see an inequality like this doubled up, it implies that it is an and inequality and that you are looking for the overlap. So you just have to know that. So this means that it is an and type compound inequality. Okay, so we just need to know that. When we go to solve it, you can rewrite it splitting it up. You could take the first chunk of it until you hit the second sign and rewrite it. and then take the second chunk of it, starting right after that sign, and rewrite it. You can do that. All right, you can split it up into two problems, but we don't need to. We can just solve it all together, solving two problems at the same exact time. We just have to, whatever we do in the middle, we have to do to the outside on both sides. Okay, so what that means is we have to add 4 in the middle. We have to do it on the left end and on the right end. That's how we keep it all even. You do it in the middle, you do it on both sides. When we do that, we are left with -2 is less than 2x is less than 16. So we copy down the whole thing, both sides included. Finally, on this one, whatever we do in the middle, which in this case we divide by 2, we're getting x alone in the middle. We again have to do it on the outsides. So that means, I'll come up here, we are left with -1 is less than x is less than 8. Okay, in order to graph this one, I am going to go by an increment of 2's. If you want to go by an increment of 1, you can. The shortcut to remembering to do this would be to know that x has to be in between -1 and 8. Right? It's squished in between there. So we kind of already know that that's where our overlap is going to occur. If we want to do it kind of like we were doing it before, we would have to, again, split this into 2 different problems. That can get a little confusing. But I'll rewrite them above. So the one problem would be easy. X is less than 8. The other one would read -1 is less than x, but I'm going to go ahead and flip that around to read x is greater than -1. So this is just kind of like a thought bubble to help me graph. So when I go look at my graph, I have an open circle at 8, shaded to the left. And I have an open circle at -1, which would be in between 0 and -2. Open circle there, shaded to the right. And I see that my overlap is, again, in between those points. So for my final answer, I should have my open circles at -1 and 8, and I should be shaded in between them. So again, on ones like this, where they're squished together, we've got one big inequality squished together, you can kind of skip over the step where you draw the arrows above it, because you know x is in between -1 and 8. And that's what we graphed. We shaded in between -1 and 8. All right, to solve a compound inequality containing or, find all values of the variable that make at least one of the inequalities true. All right, we need to solve an or inequality on example 4. So much like the and ones, this whole thing all the way across is example 4. All of it. Also, like some of the examples we saw before, we need to solve both inequalities, and then we will worry about graphing them on the same number line. So, to solve the inequality on the left, I'm going to add 1 to both sides to get x is less than 4. To solve the inequality on the right, I subtract 3 from both sides and get x is greater than 5. When it comes time to graph OR inequalities, we are going to graph everything that makes at least one of the statements true. So essentially what we do is graph both inequalities on the same line. It needs to satisfy one of them or the other one. So when I go to graph x is less than 4, what kind of circle do I want it for? Open. There is no equal to bar, so it's open, and it is shaded to the left because it is less than, so we're going to the left. So I am just going to go ahead and graph it right now. All right, then I have to also graph x is greater than 5. So do I want open or close circle at 5? Open again. And we shade to the right. Okay. And then we're finished. Once we're done shading, that's it. That is our solution set. Any of the numbers on the left of 4, any of the numbers to the right of 5 will work because we just need to satisfy one of these or the other one, not both. All right, on example 5, again, we solve both inequalities separately, and then we will graph them on the same number line. To solve the left side inequality, I subtract 9 from both sides. I get 3x is less than negative 12. Then I divide by 3 to get x is less than negative 4. On the right side inequality, I subtract 1 from both sides. I have negative 2x is less than 4. I divide both sides by negative 2. And I should have a special buzzer going off in my mind to remind me to do what? Flip it. Flip that inequality symbol around, because we divided both sides by a negative. All right, now I'm going to white out number 6 briefly so that we can have a space to graph. Okay, so I'm ready to graph. Because it is an OR inequality, I know that I don't have to worry about an overlap. I can just go ahead and graph both of these inequalities on the same number line. So when I graph x is less than negative 4, open or close point. Open at negative 4, shaded to the left because it is less than. Shading, shading. Okay, now that I've got that one shaded in, open or close point at negative 2. Open, shaded to the right. All right. Questions about our graph for this one? Yes?
What if they do overlap on these? Yeah.
If they do overlap, then your solution ends up being all real numbers.
So number 6 all real numbers.
So
They can overlap. All right, example 6. Once again, we have an OR inequality. So I'm going to solve both of them separately and graph them both on the same number line. Number 6, I divide both sides by 4 to get that x is less than or equal to 3. Wonderful. On the other one, I have to divide both sides by negative 7. Good. So that buzzer is going off in my head to tell me to flip it. Flip the sign because we divided by a negative. So we end up with x is greater than or equal to negative 3. Now it's time for me to graph both of those on the same number line. I we'll choose to count by ones. 1, 2, 3, -1, -2, -3. Okay, so again, it's an OR, so I don't have to worry about the overlap stuff like I did on the ands. I can just go ahead and graph them both. So, for x is less than or equal to 3, what kind of circle do I want? Closed circle at 3, shaded to the left, shaded to the left, less than or equal to. That one's going to the left. So all the way down here. Okay. Then, for x is greater than or equal to -3, I want what kind of circle?
Shaded.
Closed, shaded in at -3. Which there's already a shaded in line there, so that's, but I can still put my point there, and then I'm going to shade that one to the right. So again, most of it's already shaded. So that brings up an interesting situation. We ended up shading in the whole line, and from yesterday, when we shaded in the whole line, it was because what was our answer? All real numbers, or that double barred R. So this is a situation where anything and everything works. All real numbers. It is possible to shade the whole line with an OR. Okay, for this problem 7, I just want to show you one more situation that we have not come across yet. So we're going to imagine it's already been solved. We already have our x's alone on both of these inequalities. It is an AND inequality, so I know that when I go to graph it, I am looking for where they overlap. 0, 1, 2. Nice, big, easy graph. So let's do our little notation above the number line. If I am looking at x is less than 0, do I want open or closed circle? Open, and I would shade to the left. Very good. Open, shaded to the left. And if I've got x is greater than or equal to 2, what kind of circle do I have? A closed, shaded in circle, and I would shade to the right. Now, this one is interesting because if it's an AND, I want it to overlap. Does this overlap at all? No. So that means no solution. So we would leave our actual number line blank and just write no solution. It's fine if you leave this little notation above it. Don't graph anything on your number line because there is no solution.